Welcome to Samuel Academy. I want to describe the angle properties of a circle. The first case involves the angle at the center. Like in this diagram, we have this angle at the center, which is 110 degrees, and this angle at the circumference. So the angle at the center here is twice the angle at the circumference. Now these two angles, this and this, they are subtended by the same chord from here to here. Okay, and they lie in the same segment. So at the center, the angle formed is 2 times the angle formed at the circumference. Even here, the angle formed at the center here is 180 degrees because this is a straight line. And the angle that is formed at the circumference is a right angle. So for the two angles at the center and at the circumference, when they are subtended by the same chord and they lie in the same segment, the angle at the center is twice the angle at the circumference. Next is about inscribed angle theorem. An inscribed angle, its vertex is a point on the circumference. Like this angle ABC is an inscribed angle, and the vertex B is a point on the circumference of the circle, and its sides, the sides of the angle AB and BC, they are chords of the circle that passes through the vertex. That is this circle which passes through this vertex P. Similarly for this angle P, ABC, this angle P is a vertex on the circumference of the circle, and the chords AP and BC are the chords of this circle which passes through this point P. So the theory is that the two angles are equal. Angle ABC is equal to angle ABC. That is inscribed angles. And you realize that the two angles are subtended by the same chord called AC. So they are subtended by the same chord, they lie in the same segment, and they are equal. That's the principle we have learned there. Similarly here, these are the two angles, this angle and this one, this angle. Each one is 70 degrees, and they are subtended by this chord. So these angles, their vertex is a point on the circumference, like that, and they are equal. Next, Thales Theorem, which states that if a triangle is inscribed inside a circle, like this triangle ACB is inscribed in this circle, and one side of the triangle is the diameter of the circle, like one side AB is the diameter of this circle, then the angle opposite to that side is a right angle. So the angle, this angle that is opposite to this side AB, which is the diameter of the circle, this angle is a right angle, always. So any angle that you can form in this segment, and just AB as one of the sides, will be a right angle. That is Thales theorem. Next is alternate segment theory or Tangent-Chord theory. Okay, this circle here has two segments, this segment and this segment. So this segment is an alternate segment to this one here. Alright. any circle, the angle between a chord and a tangent. Like this circle here is the tangent. The tangent just touches the circle through one point. At this point is the tangent. Okay? So in any circle, the angle between a chord and a tangent, like here, the angle between this chord and this tangent, through one of the endpoints of the chord is equal to the angle in the ordinate segment. We have this circle, we have this tangent, and we have this chord. So the angle formed is 90 degrees. Now this angle is equal to the angle in the ordinate segment, this one here. Even here, this is the chord, this is the tangent, this is the angle formed. So if you form an angle using this chord as, if you subtend an angle on this chord, that is the angle you get in this segment. So this angle is equal to this one here. That's called the ordinate segment theorem or Tangent-Chord theorem. Next is the perpendicular tangent theorem. It says that the radius from the center of the circle is the radius from the center of the circle to the point of tangency. So this is a tangent. This is a tangent. It just touches the circle through one point here. So the law says that, the theory says that the radius from the center of the circle, this radius, to the point of tangency is perpendicular to the tangent line. So this radius is perpendicular to this tangent. So at this point, the point of tangency, the radius is perpendicular to this tangent. So the angle formed is called the right angle, 90 degrees. Then you have tangents to the circle from one point. Like this is a circle, we have two tangents, OA and OB. Now, the theorem says that tangents to the circle from a point of the same length. So this tangent OA and this tangent OB from point O, they are of the same length. OA is equal to OB. That's a very important theorem. Then we have a cyclic quadrilateral. That is a quadrilateral that is inscribed in a circle. So we have this circle and we have this quadrilateral A, B, C, D. So this theorem says that the sum of the opposite angles in a cyclic quadrilateral is 180 degrees. So this quadrilateral inscribed in this circle, this cyclic quadrilateral, the sum of angle A, B, C and angle ADC is equal to 180 degrees. So this angle plus this opposite angle is 180 degrees. Or this angle A and this angle C, their sum will give you 180 degrees. That's the end. I'm sure you have got something. If you find it helpful, please subscribe to my channel.